Now, for integer multiplication, we'll just follow the same convention. Blue is positive and red is negative, and so here we have three groups of -2. So we have three groups of 2 red chips. And so we can draw a model that has three groups of 2 red chips. And how many is that together? That's -6. So in total we have -6. Now what if we have -3 times -2? Well, now we're going to interpret this minus as remove 3 groups. So remove 3 groups of -2. So suppose we start with 0. We can add 0 to it as many times as we want. That's all of these so-called 0 pairs, right? We can do as many of those as we'd like. And so I need to get it to where I have enough negative chips. I need enough red chips that I can remove 3 groups of 2. So I add 6 of these 0 pairs. Here's a group of 2 red chips, a group of 2, a group of 2, and then we remove 3 of those. And so those are gone, then all that's left are these 6 positive chips, and so we are left with 6. So -3 times -2. When I remove 3 groups of 2, I have a total of +6. And so I think of all of the models, this is probably the most complicated, or the most confusing, unintuitive. I don't know what word I'd like, but this is the one that requires really the most practice. Is you're like, so I'm removing, but I think if we remind ourselves, positive is blue and red is negative. And so that I can just immediately translate this -3 times -2 into remove 3 groups of 2 red chips. It kind of makes it a little bit more clear what we need to do. Another way we can think about this, we can think of it as the opposite of 3 groups of -2. And so we have 1, 2, 3 groups of -2, puts us to -6. And then its opposite means its distance from 0 is the same. And we're left with 6. And so we can use either of those models to represent. And you'll see that really throughout all of the integer work, we're going to stick either with set model or number line model. I know for some other ones we had other models and representations, but this pretty much is the limit of what we'll work with in terms of negatives. But there is a pattern model, and so I want you to see this because one of our standards for mathematical practice is make use of repeated reasoning and finding patterns. And so if we need to find -3 times -2, well, first times 3 times -2, well, that's -6. And 2 times -2 is -4. 1 times -2 is -2. 0 of them is 0, and so we would expect -1. Since each of these is going up by 2 each time, I would expect this to become +2, +4, and +6. And so we can see how that continues the pattern that we need in terms of how these operations work. And so there's the typed version. So just like with addition, something I didn't mention but is important. We have closure of subtraction of integers. So an integer minus an integer is an integer. So with whole numbers, remember we didn't have closure because 3 minus 5 wasn't a whole number. It was -2. But now, because subtraction can be negative and we've included all of the negative integers, we do have closure of subtraction. We also have closure for multiplication. We have commutativity for multiplication. We have associativity for multiplication. We have our multiplicative identity, so multiplicative identity. That means, and we call that multiplicative identity 1. A times 1 is A. It doesn't matter if A is 5, we get 5 out, or if it's 10, we get 10 out. Now for distribution and multiplication over addition, we had that for our natural numbers, so that's not too surprising. But we also have multiplication distribution of multiplication over subtraction. We didn't guarantee this unless we had already guaranteed that C was less than B for our whole numbers. And so now it doesn't matter because it can go negative. And then we have what's called the zero multiplication property. Any number times 0 is 0. And the same is true for 0 times a number. So if you have, no matter how many groups of 0 you have, you're left with 0. And also, if you have no groups, it doesn't matter how big they are, you have 0. So remind you of, so that's no groups, pretend, and that is group size is 0. And then we have some new properties for negativity. So -1 times something is the opposite of that something. So that just means we can pull out a negative. If I have a -a times b, because I have -1 times a times b, I can rewrite that as a times -1b, which is a times -b. Oh, that's actually supposed to be a and b. I'll fix that in the uploaded version. And then -a times b. It doesn't matter where the negative falls, you're good, and we've already shown this. But if you take away red chips, you get a positive number. And so see, right, like I'm giving these properties formal kind of formal definitions and kind of really being formal in terms of the algebraic representation, but it's important to remember that this is just formalizing the things that we've already seen. We saw that taking away red chips gave us a positive number. And we didn't necessarily show that -1 group of a number is the opposite of that number. But we could very easily show that if we are taking away a group of, say, 7. Actually, I'm going to write that. I'm going to switch to my... And that bag was probably really loud. So I need a red, and I don't see blue. Is it okay if I use black? Okay, it's blue. So suppose I have -1 times 7. So I have -1 times 7. Which when we reinterpret that, it is take away one group of 7. So if we're taking away one group of 7, and we go ahead and start by putting 7 zero pairs, so we have a negative, -3, 4, 5, 6, 7, 1, 2, 3, 4. And I think you'll agree, since I have 7 zero pairs, that this is 0. But I'm going to take away one group of 7, so this is my 7. Take away. What am I left with? 7 red ones, which is -7. And so that is a proof of why that is the case, right? So because that works, we showed with the model that when we take away one group of 7, we're left with 7 positive chips. No, we're left with 7 negative chips. So -1 times 7 is indeed -7. Maybe let me write that just to finalize it. -1 times 7 is indeed -7. Good. Now integer division. For all integers a and b, a divided by b is the unique integer c if it exists such that a equals b times c. So remember, when we were defining division of whole numbers, what we cared about, right? So when we were defining division for whole numbers, we required that the result be an integer. There couldn't be any fractional parts. We had to talk about how many times it would go in and the remainder perhaps, but our result had to be a whole number. And likewise here we're requiring that they be integers, so we still don't have fractions. So 4 divided by negative 2 is defined, but 4 divided by negative 3 isn't. And so for example, negative 15 divided by 3, you just have 15 red chips. You're splitting it into 3 groups. 5 negative chips in each group, so we get negative 5. And so really, remember, what we want to reinforce is the inverse relationship between operations. So multiplication and division are inverses. And so since we already have a number of tools for multiplication, we can just translate division to multiplication to work through it. So what we have, if we have negative 15 divided by negative 3, well, first we'll rewrite this. Some number times negative 3 gives us negative 15. So how many groups of negative 3 do you need to get to fit negative 15? Well, at this point now it's repeated addition, and you just need 5. So 5 groups of negative 3 give us negative 15. And that's integer operations in a nutshell. So I hope what you'll see by looking across today's video, which is a relatively short one, and I think a couple of them this week will be relatively short because we did a lot of building up work in the first 2 weeks. We spent a lot of time talking about the concept of addition and multiplication and their inverse their inverse operations, subtraction and division. And so since we spent all of that work building up sets and operations and our meanings for those, now when we just tweak a little thing, we let subtraction go negative, or tomorrow when we let division go fractional, we're just going to see little changes, and we're going to see there aren't a ton of new things to introduce. But there's still enough here that I think it's worth digging into for a full day. So the homework from today will connect to a lot of these ideas about integer addition, subtraction, multiplication, division, particularly with working with and modeling negative sums, differences, products, and quotients. And tomorrow we're going to start to really dig into the meaning of fraction before moving on to operations with fractions. And so that is integers and their operations. I will see you in the next video. Bye, everyone.